Imagine you're standing in a massive sports bar, right? You've got 40 screens showing 40 different games in just perfect 4K.
Right.
But what you don't see is the absolute logistical nightmare hiding behind the drywall. So welcome to the deep dive.
Yeah, it's a completely different world back there.
Exactly. And today, our source material is this highly technical spec sheet from HDTVSupply for the Smart-AVI RK8-HDX-POE-S. I mean, it is basically an 8-port HDMI extender. But our mission today is to decode how this roughly $1,500 piece of rack equipment actually tackles the brutal physics of commercial AV setups.
Well, it's a pretty dense read because when you're dealing with professional multi-screen environments, you hit a wall fast. You aren't just plugging in a monitor. You're actually battling severe bandwidth limitations, signal attenuation over long cable runs, and, complex power distribution.
Okay, let's unpack this. Because if you're pushing 4K to 8 different remote displays, managing that physical infrastructure just gets ridiculous so quickly.
Oh, absolutely.
Like, if you use individual extenders, you're forced to install separate power supplies and dedicated outlets for every single receiver behind every single screen. It's just a total spaghetti monster of cables.
Which is exactly why this device is engineered as a centralized 1RU, or a single rack unit solution. It takes 8 inputs and 8 outputs and handles them all from the central server rack using just one single power supply.
Wait, really? Just one?
Yeah, just one. You're completely consolidating all the power logistics.
But wait, consolidating the power of the central rack solves one problem, but then it immediately creates a much worse one. Right. Now your video source is miles away from your actual screen. And the spec sheet says this transmits up to 250 feet. So why wouldn't you just run a 250-foot HDMI cable through the wall and call it a day?
Well, because of the physics of signal degradation. I mean,
Yeah.
HDMI simply wasn't engineered for long distances at all. Once you push a standard HDMI past about 50 feet, the signal just rapidly attenuates.
Okay, so it just degrades.
Right. And since HDMI lacks robust built-in error correction, dropping packets doesn't just mean a slight blur. It means visual artifacts, severe lag, or, honestly, just a completely blank screen.
Right, so instead of trying to force a video cable to do something it really hates doing, this device completely sidesteps the issue by using standard Cat-5e or Cat-6 network cables.
What's fascinating here is the actual mechanism behind those network cables. Ethernet cables use twisted pairs of copper wires. That specific internal twisting naturally cancels out electromagnetic interference over long runs.
Oh, wow.
Yeah, so maintains data integrity over distances where standard HDMI completely fails.
We're talking about a massive volume of data here, like the spec sheet lists 10.2 gigabits per second. To put that in perspective for you, 10.2 gigabits is roughly the equivalent of downloading a full-length, uncompressed HD movie every single second.
It is a massive amount of throughput.
Yeah, pushing that volume of 4K video at 30 Hz plus Dolby True HD lossless audio through a standard networking cable is just a serious engineering feat.
And it's not just handling data either. Standard HDMI cannot carry the heavy electrical current needed to actually power a remote receiver. This is where power over Ethernet or PoE comes in.
Right.
The main rack unit sends the raw electricity needed to run the receiver box down that exact same Cat-6 cable.
So you're essentially hijacking a cable built for IT networks to carry pure electricity, high-res video, and IR remote signals all simultaneously. It's like a municipal water system sending the water and the electricity to run the remote pump through the exact same pipe without them interfering with each other.
Exactly. And if we connect this to the bigger picture, that's the real paradigm shift. Modern, high-end audiovisual setups are no longer about video cables at all. They have evolved entirely into IT networking problems.
So what does this all mean for you at home? Well, whether you're wiring a commercial venue or building an absolutely uncompromising home theater, understanding this equipment really changes how you view infrastructure.
It completely changes the physical blueprint of a building.
Yeah, you stop thinking about running video cables and you start thinking about network architecture. You don't even need to install power outlets behind your screens anymore.
It is just a much cleaner solution overall.
Which leaves a final, lingering thought to explore. As our displays demand heavier and heavier data rates, pushing past 4K into 8K and beyond, will our physical spaces require commercial-grade, hardwired server racks like this one forever?
That is the big question. It raises an important point about the hard limits of our wireless infrastructure. Because at a certain point, the airwaves simply become too crowded to guarantee uncompressed quality.
Right, and until we crack that wireless code, The real heavy lifting is going to stay hardwired. So the next time you're standing in front of a wall of perfectly synchronized screens, just remember the networking architecture quietly making it all happen right behind the drywall.